In our last video, we talked about observational studies. Now we're going to turn our attention to experimental studies. So we saw that an observational study is collected by monitoring what occurs. We decided that this can be done either by watching it as it occurs or collecting data retroactively, or retrospectively was the term we used. The example we used is we want to know how many students run a stop sign on the northwest corner of campus. Well, with experimental studies, what we're doing now is we are introducing a new variable that is going to be tested. We want to know, if I introduce this new variable, will it affect the observations? So, using the example of running stop signs on the northwest corner of campus, we might change that to, does posting a police officer at the northwest corner of campus decrease the number of people who run stop signs? And in this case, you would do an experiment, you would do an observation, just see how many people run the stop signs, and then park a car right there on the corner and just see if people see that car, will it reduce the number of people who run the stop signs? You just observe, and then you compare the two situations and see if there's a difference. So with an experimental study, you're going to have two groups. You're going to have a treatment group and a control group. You guys have probably heard about control groups. We talk about them fairly frequently in just everyday life, really. But what is a control group? A control group is the portion of the sample that is unaffected by the tested variable. So with the running the stop sign example, the control group would be those who are observed when the police car is not parked at the corner. So we did not introduce the new variable. The treatment group, on the other hand, this is the portion of the sample that is affected by the tested variable. We are going to, this is the group that you observe whether they run through the stop sign or not when the police car is parked there. The new variable is in place. We're going to see, is this going to affect the results? So, for example, you could take a second and do this on your own. You're going to offer cookies to students walking by the math building. Question is, will more people choose to take a cookie if a larger variety of cookies are offered? So, what you can do to design a study for this is, first of all, what sampling method are you going to use? How are you going to test the variable? Who's going to be your control group? Who's going to be your treatment group? And then ask yourself also, are there any confounding variables in this study? So, for example, I might create a study to answer this question. By the way, if you haven't, go ahead and pause it. See if you can design a study for this question on your own, and then unpause and see my answer and see how they compare. So what I would do for this study is I would perhaps have, thinking of the best way to do this, maybe for 1 week, have a table out by the math building and offer a free cookie. And maybe each day you do it an hour a day in different times of day so that you are getting different people. And then the next week, do the same thing, but this time instead of just one type of cookie, you now have a variety of cookies, and then you collect data that way. That would be a good experimental study. So 1 week, having the table out at a variety of times with one variety of cookie. See how many people take the cookie, and then do the same thing the next week, but with a variety of cookies instead. So what sampling method would I be using here? In this example, it's just people walking by. This is likely to be a volunteer response sampling method. My control group would be the people in that first week who are just selecting a cookie when there's only one type of cookie offered. My treatment group, they are now being exposed to the variable I want to test. And that variable is if I have a variety of cookies. So the treatment group would be that the data from the second week where um, I have a variety of cookies for people to choose from. Are there any confounding variables? Well, yes. One was the table out in between classes. What time of day was it? What was the weather like in general? Let's see, what other confounding variables might there be? Allergies. People might have allergies to allergies to gluten, so they don't want cookies. And so then at this point, when you think of all these confounding variables, you want to go back and say, how can I minimize these confounding variables? All right, let's move on. Now, the example of the cookies, separating the control and treatment groups was pretty easy, but in some cases it can be a little more complicated. How do you divide the control group from the treatment group? Well, there are three basic ways that you can do this. You can do it completely random. Maybe assign everybody a random number. If it's even, they're in the control group. If it's odd, they're in the treatment group. Just completely random. Make it very random. The second would be a blocked experiment. This is very similar to the stratified sampling method. With the stratified sampling method, remember we took our sample, we took our population, divided it into groups, and selected a percentage from each group. With a blocked experiment, we're going to take our sample, divide them into groups, and then take half of each group, put them in the control group. Sorry, let me say this again, just so I'm not confusing there. You take your whole sample, divide it into strata or clusters. We'll call them clusters. And then take each cluster and divide it in half. Half of them would be in the control group. The other half would be in the treatment group, and do that for each cluster. That's the idea of a blocked experiment. Now, here you have to consider, what variable am I going to use to separate my sample? Could be by gender, could be by age, it could be by grade level. Generally, it's some sort of a categorical variable where we gather that and then we separate our sample based on that variable, then divide each cluster in half. Okay, a matched pairs experiment. This one's pretty cool, where you take two members of your population, or in this case, members of your sample, and match them together. This is done based on characteristic. You find two members that have very, very similar characteristics, and you match them together. And then you randomly select one to be in the control group, the other goes into the treatment group. That way, when you have matched characteristics, it minimizes a lot of the confounding variables that you might encounter. And then you could just directly compare those without the treatment to those with the treatment, with minimal bias from confounding variables. So, perfect. That's the basic structure of how to do an experimental study. In our next video, we're going to talk about blind experimental studies and how to make it so that bias isn't introduced when those people you're sampling know which group they're in, and how that could affect the outcomes.